We're solving problem 14 from the AMC 10B from 2017. An integer n is selected at random in the range n is greater than or equal to 1 and is less than or equal to 2020. What is the probability that the remainder when n to the power of 16 is divided by 5 is 1? When you see divided by 5 in remainders, you probably think of modular arithmetic, and this is true, where we can simply count the cases. If n is congruent to 0 mod 5, then n to the power of 16 has to be congruent to 0 mod 5. And we can keep on doing this 4 more times, because mod 5 is only the numbers 1 to 5. Or 0 to 5. Wait, no. 0 to 4, because 0 counts as a number. And then, if we do this again, n is congruent to 1 mod 5. And then that means n to the power of 16 is congruent to 1 mod 5. And this one works, because it has a remainder of 1, and this is what 1 mod 5 is the remainder of 1. So we keep on doing this process, and congruent to 2 mod 5. N to the power of 16. If we set it equal to 2, then this is going to be 4 to the power of 8. And this is actually going to be congruent to 1 mod 5. And it is still, because we're just looking at the last number, if it's a 6. Or, yeah, if it's like, the last number has to be 1 more than a 5. And we see that it works because 4 squared is 16, and the units digit is 6. So this also works. N is congruent to 3 mod 5. N to the power of 16 is congruent to 9 to the power of 8. And by similar logic is also congruent to 1 mod 5, because 9 squared, its units digit is 1. So this is 1 mod 5. And now let's do n is congruent to 4 mod 5. So n to the power of 16 is congruent to 4 to the power of 16. This is essentially this case down here. If this is congruent to 1 mod 5, this has to be congruent to 1 mod 5. Because you're essentially just you're increasing the exponent, you're squaring it, yeah. And then, yeah, these are all the cases, 1, 2, 3, 4, 5. And we count all these 4 out of the 5 only possible cases are 1 mod 5, so this is our answer, 4/5.